Alright, I think I'm live again. Is this true? Let's check. New channel. How did I do this last time? I'm retarded. Can't remember. Right, so if this is it, how do I go to, there's like the screen manager, right? Or can I go to that on OBS? Not explore, but here maybe, go live. Here, there we go. Right. Manage, maybe. This thing is live now. Okay, I should be good. Excellent connection, nice. So yeah, it's almost 2. Haven't really done anything today. What the fuck? Now I'm live again. Yeah. So I should do some work. So what work should I do? There was this thing. Let's see. This Mathematica notebook. Doesn't open in Mathematica, that's weird. But yeah, so this. So it's interesting because right, so here we go. Here we have, what I'm doing is I'm solving the scalar field equation of motion in 5-dimensional anti-de Sitter space outside of the horizon with the correct boundary conditions. And so I get this result, and this result is like pretty good. It's not bad. Like pretty simple because I can write it in terms of hypergeometric functions, but it is curious. It is curious because so from this I can extract this thing. And let's take a look. So let's take a look. Well, because this is, yeah, so let's start with this. Maybe let's make a new notebook. Let's call this 11 scrap. And so this is my wave function. Yeah, so I mean here beta bar is so beta tilde bar is equal to R1 over R0 squared plus R1 squared, and beta bar, so it's this with R0, right? So what's R1 over R0? This is, so I want to solve R1, so this is this thing. Let's solve for R0. What do we get? We simplify that, it doesn't really matter. And we want to look at the big black hole. If we want to look at the big black hole, then we want to look at the second one. Because there are 2 black holes of the same temperature. There are 2 black holes of the same temperature. So this is so beta bar is like 2 pi over the temperature, and yeah, so now what I want to do is I want to consider beta bar, so this thing is 1 plus 2 of these. So this is 1 plus R0 squared. And I am solving for this. Right. So let's assume beta bar is greater than 0. I want to simplify this. And this is pretty fucking messy. Yeah, it's not good. It's not good. How am I to understand this? And what is the maximal value of this? Let's maximize. 1 plus 2, and this goes from R0, 0 to how am I supposed to do this? Mathematica, maximizes, oh, do I just do R0? Right. And so it's less than this, but it's also, it's greater than 0, but it's also less than this. And I should simplify it all. The problem is, see, this is the problem, right? The problem is, if I add I over beta bar, as I'm supposed to do to compute lots of things, so that's fine. This, I replace this with this thing. I replace this with, well, yeah, let's get these, whoops, let's get these things going, and same thing here. Right, so this stays, nothing changes here, and now I pick up this I beta bar, so this is just 1. Yes, that's fine. And this is also fine because, well, the beta bars cancel out, and this really becomes -1. And this is fine, because if there's -1, I can write you in terms of whatever. Similarly, this is minus I beta bar omega. Beta bar cancels with this beta bar. Oops. These i's cancel out and give me +1. So again, this is good, because I can simplify this in terms of the other thing. Yeah. But this is more difficult. Because I can well, let's do this thing, and this thing, minus, yeah, so this is minus now, this is minus now, so this thing doesn't change. However, this thing changes. This is the new change. So, and that changes, that goes away. So, minus I plus 1. That's And of course there's a 1/2 there. That's fine for the most part. I just don't know how to deal with this. Because because this thing is beta bar over, so this is like R1 over R0. And yeah, I don't know how to deal with that. Because I can't use a gamma whatever identity to rewrite that as in terms of shit. I don't know. It is confusing. Let's put on some music, maybe. Some Schubert. Oh, that's weird. I'm not connected to computer. There we go. Nice. 0 viewers, that's how I like it. Yeah, this is confusing. Alright, because this is like one. Yeah, this 1/2 here is very annoying. If I slide this by even here, because it sends it by I/2 instead of. I do not know. I do not know. So what do I do with this expression? I could try to see if there's an SF2R in the large scaling of it. It's quite unwieldy though. Like this is not. What do I do with this factor? I don't fucking know. Oh, I don't know. Let's keep trying. there. And I let this I slide. Well, before that, let's bring this over. This bit of R cancels this bit, so this is R1 over R0. And now I minus 1. Oops. Right. Plus, I can bring this here, and I can bring this here. And that makes sense, right? If this is minus, yeah, this makes sense. And I can do the same thing here. Bring the beta bar inside. This is R0, sorry, R1 over R0. With the I through. 1 plus this shit. Yeah. And this should just be the same, just with the minus instead. Bring the I plus R1 over R0. 1 plus this thing. Jesus Christ. Yes, that is it. Maybe I can. Maybe I can make this a little better. So that will be right. That's what I called it. This thing is Kelby, and this is Kelby conjugate. So I'll denote that by with the extra C over here. And there's also the C over here. So, like, this is just a 1. I can, no, well, it's not just a 1. It's right. This 1/2 is quite annoying. So let's make that as explicit as possible. Let's bring this in here. Maybe that'll make it a little better. This is divided by 2, multiplied by R0. Yeah. And same thing. This is just going to be reminded. Well, yeah. So minus this thing. Oops. Kill yourself. Minus this thing. And what the hell do I do now? Oh, there's an R0 here. How did I miss that? Well, actually, I think I should do something like this. That'll make it more clear. Right. What the hell is this? I don't fucking know. Well, I suppose we can see, can't we? If I divide this by the initial, without this other factor. So here Q is irrelevant because I'm looking at the approximation where the, yeah, this doesn't, so now I'm just dividing by this enormous thing. So these go away nicely. Whoops, that's not what I wanted to do. So what I wanted to do is this and this thing. So this is easy to compute, right? Factor. Yep. Okay. If I multiply it by minus I, this becomes 1, this becomes I. Nice. Well, not nice, but it is what it is. Right. Yeah, I can replace this with cal B, is what I call it. And same thing here. Cal B. This is cal B conjugate. And same thing here. And let's make these a little more explicit too. Yeah. So to do that, let's make these disjoint. And this is divided by, so I should. Yeah, see, I'm not too sure what to make of this. And same thing here, right? This gets flipped. This gets flipped. Whoops. This gets sent here. And this. Oops, other. Wait. I'm confused. So yeah. What I meant to do was this guy gets sent here, and this thing gets sent here. Right. And so now I have a bit of an interesting. Thing going on. So this is expected, more or less. Whatever. Okay. this is also fine. Except this, I have no idea how to think of it. Maybe. So these are like conjugates. Not quite. No. These are like conjugates. These are like conjugates. Well, not quite conjugates, but they're flipped conjugates. No, that's just bullshit. Well, I should be comparing. I should be comparing these. Is that correct? Like. If I flip this. Going on here. And now I need to take the scaling limit as both of these become large, right? Yeah. Okay, so that's not uninteresting. Whereby this one half, well, no, that's pretty lame. Like this one half cancels this one, and so I have something like this times something like this. R1 over R0 is like square root of 1 plus 1 over R0 squared. What happens if I take the block hole to be very large? If I take the block hole to be large, then R1 is the same as R0, so this is just 1 minus I over 2, or 1 plus I over 2. And still, I don't know what I'm going to do with that. I'm not sure. I am not sure. Well, half-sided translation. Let's choose to do something like this instead now. And let's see. Why am I tired? I can take some Vyvanse or some caffeine. What's it going to be? Let's take some caffeine. Oh God. Why am I alive? did have what we have is something. I guess this goes to show just because your argument could be written in terms of local to F1s does not mean that the transformation is global. No. This requires. This is a statement about the spacing of quasi-normal modes. But the real question I want to ask is. Oh wow, that placebo working already. Maybe it's just drink some cold water to make the caffeine go down. Anyways, what am I talking about? I got an email. Let's check that first. Ooh, right. Oh, you know that free lunch. That does look pretty good. Now until 3 p.m. E51, E225. Rice with vermicelli. It'll probably be all gone. Hummus, shawarma. It'll be all gone by the time I go. And so I should just stay here. What did my friend just send me? Oh, really? That's funny. Wow. Anyways. Minkowski half-sided translations. Right, so what I want to do is I want to compute something. I want to compute, what is it that I want to compute? Well, there's infinitesimal action. I don't want to compute the infinitesimal action. I want to compute the full action. This one? It's in one of these, I don't remember which. I think so, right? Yeah. That's right. Well, I guess there's no... I could do this again. There's no rush. There's no rush. Finite half trans. Right, so this should be one of these. This is going to be the half-sided translation structure. Yes. And now I just compute shit, right? Well, let's go back to 911 scrap. No, it's this one, 909 scrap. Moral, I got this nice moral of this being my wave function. But now, okay, this is interesting because now I can take the boundary limit, right? And if I take the boundary limit, then again, interesting things happen. Question mark? Do they? No, I don't think so, because the algebra does not depend on... Well, it does, and it doesn't. doesn't. It doesn't. So if I take the boundary going to so if I then this would be the expression I want. This one. This goes to 0. This goes to this is vanishes some factor of w to the omega. It's fine. That's what I expect. And I'll just get this. Right? This is I'll get. And if I take I don't know. The boundary limit, I can look at that later. Another one of these. What is this? Oh, sorry. 9/11. 9/9. -6. That's not what I want. Yeah, let's just continue, shall we? With this the thing. Alright, and now I just multiply, right? Well, actually, let's go to y. How did I define what y is again? Yes, y is over here. What is this thing? Okay. So this is y, this is y. That's all fine. This is 4 over y, and this is also 1 over y. Now what is this thing? Yeah, so this is what r is. R over r squared, rather. R squared equals this thing. And now we just simplify 1 minus y. 1 minus y. Where does this thing come from? I think this comes from the let's compute this thing. Assuming r greater than 0, r greater than r0, r greater than 0. Doesn't really help. Well, I don't know. Doesn't matter in any case. we hit the horizon and y goes to 1, then r becomes infinity. And that's alright. Okay, I quite think that's fine. I think that's fine. Maybe fine. Maybe we can do like our zeros. Those are 1. That's bullshit. So let's see if these are equal. And I can split it interested. Oops. Let's solve for what is y in terms of r again? Just tell me this is true. Perfect. And I can even put this here. Nice. So this is what? This is what? Yeah. And now let's put this thing is quite explicitly. So that's this. And yeah, now we just put everything in its right place. Yeah. That's fine. VK prime. Okay. So that's what this is, except I just replaced this with minus s. And now I put this here. Except I need to make every one of these prime. That's fine, that's fine, that's fine, that's fine. That's, well, there's no cube, so. Yep, that's alright, that's alright, that's alright. So it's really just the function we make it at this point. And still, it's quite difficult, right? It's still quite difficult to study the possibility nodes. Well, nothing to be done about that, I suppose. And yeah, now we just simplify. K prime is really just like a prime cube. In this case, just yeah, so let's move this here. I can bring this outside. Yeah. So this will just be this thing. All right. This is just a delta 1. I needed to distinguish that earlier, but not here. Here it's fine. Yeah. This is all just fluff. suppose, well, this becomes squared, and this gets rid of this. Nice. Right, let's bring the S bit out. And this is the minus omega P. P minus I R omega P divided by T omega R. Yep. And so now I can just take this and I can pull you forth. Pull you forth in here. Okay, that's quite nice. Now, this thing stays because of course it has to. And there's a yeah. This is kind of funny. Because I have this thing over here. At the cost of inverting this and taking its square root, I can bring you in here. This thing I really don't need to. I just need to take its square root and lock it here. Now I get, yeah, two kind of let's flip you. This is just the constant. What is important is this y over here. This is inverted. Alright, that's fine, that's fine. There's like these things, right? Oh yeah, I forgot about beta bar. How did I forget? And then that means that has to be there, and of course that means that there's beta right here, and there's beta right here. So now Now this thing should simplify, right? This thing should simplify to this. Yeah. And on the contrary, since this thing, and this thing should be flipped to the right. bring this in here as well. Maybe here's a better place for it.
Every day. I never cook. I keep an empty refrigerator. My dad's like, son, don't you think it'd be so much cheaper if you cooked? I said, let's talk about that scenario. Calling the valet, getting downstairs in the elevator, getting in the G-Wagon, sitting in traffic on Biscayne, trying to find a parking spot at Publix, looking around the store for what I want. Dude, I want chicken or steak. Getting the food, all the ingredients, going home, parking again, going back up the elevator, getting the pots and pans out, cooking like an idiot. I'm cooking, saving money. The Dial soap that costs $8 a little bottle. Oh, clean the dishes, clean the plates. Nerds. I eat Uber Eats every day. I never cook. I keep an empty.
Is this very real? I can't tell if this is satire. Probably, right? Actually, I don't. I'm not sure. I'm not sure. So now I take this thing. Yeah, so these are all primes. So I can bring this in here, and this will cost me something like this. That's fine. Well, no, sorry, this all kind of simplifies, right? Let's, oh god. These are all in the lower half plane. goes to, no, when y goes to 1. Yeah, this is kind of complicated. Yeah, now how the hell do I do this integral? How the fuck do I do this integral? This is very messy. Let's see. I think this should be okay. So the beta bar and the beta bar. So these actually can't. Jesus Christ! I can't even use this asymptotic behavior because. Yeah, I don't know. I don't know the asymptotic behavior of this hypergeometric function because this will be like a omega p b omega p prime and a plus b omega prime, but it's not just 1/2 1/2 1. It's fuck. This is quite complicated. I don't know what. I don't know what the asymptotic behavior of this hypergeometric function looks like. There's this thing with Stokes lines, right? Like in certain radius of changes. Maybe like they talk about this in they talk about this in their expression. Let's see. They don't though, right? They don't. Okay, yeah, this is that thing. Analytic continuation. whatever. Listen to the notes. Where are the Stokes lines? Where are the fucking Stokes lines? I don't know what the Stokes lines are. Okay, well. They can probably compute it for something like this. This is very frustrating, right? That this beta bar is here. If R0 is very small, then this approximation breaks down, so this is no good. This is no good. 8.5. 0 sophisticated WKB analysis. This is not a WKB analysis, this is just solving the equation of motion in a certain regime. An alternative approximation, this is to a Bessel function. It's valid everywhere near the singularity. We could consider that. Yes, we can compute these propagators into 2-point functions, but I don't actually want the 2-point functions. I want 3.24. Yeah, that'll give me something very messy that I've tried to do before and wasn't just complicated. It's the problem is because the quasi-normal modes are not purely vertical in the complex plane, right? They're shifted by this horizontal component that's given by beta tilde bar. And this is actually, like, in no limit is this negligible compared to beta bar, because R1 is bigger than R0. At best, R1 is equal to R0, and so we have these 45-degree angle lines. This is very frustrating. I don't know what to do about this. It is frustrating. Fuck. Stokes lines. Yeah, this is not quite a Stokes approximation. So what's weird is I can actually do this sum, although it'll probably be horribly messy, and I can't simplify it into something involving 2f1s. Again, it's because of this. But so yeah, this is interesting, right? The difference compared to BTZ is that this beta tilde bar would also be there, except it just doesn't depend on omega prime. Interesting. Yeah, so if I try to do this approximation, this alternative approximation, for D, it's also going to be messy. Basic idea is if the Bessel equations, and then we can match these. Suppose so if spatial moment is not too large, and the mass of the scalar field is also not too large either. So in this case, we can find the quasi-normal modes. You can compute the residues here. It's fine to 1/1. Yeah. Stirling formula. Yeah. The exponentially subdominant terms. straight lines extend radially to infinity. In the large mass limit, these are the quasi-normal modes, and you have weird analyticity things. I don't know. Yeah. Now where do we find the reduce? So my y goes to 1, which is the boundary. This gives the desired scaling. This is just some prefactor, whatever. Offsets us. This is 1, this is 1. That is the difficult part. I have no idea what. So even if I use this other form, if we go back to this this thing, and if I want to take the large mass limit of this guy, if I take the limit as omega is large, then if it were not for or I omega is larger, I suppose. If it were not for this term, I think I would be fine, right? But alas, I do not know. Minus beta minus beta minus beta over 2 minus beta over 2 minus beta. These two add up, and those two cancel. Is there a typo here? I don't know. Is there? Not sure. Doesn't look like it. I think this is fine. Yeah, it's just yeah. We can try to do this quasi-local analysis again. We'll have S to the to the minus t or some shit like that. S e to the beta over beta bar. I don't remember. I think so, right? That's what this will look like. S e t beta bar. T over bar, and this it will scale as minus I omega prime beta bar, and this will hold true universally so long as there is a time like killing vector. Well. This will be true so long as there is some killing vector. So, for instance, in like a Kerr black hole, it's just going to be omega minus angular, like capital omega. Running out of coordinates. Omega minus. The capital omega, lowercase omega, so like frequency minus the angular rotation speed, capital omega times t. That is what it will be instead. E to the omega t. Yeah, so like if that scales as S0 and S1 will differ how? I don't know. I don't know how S0 and S1 will differ. S t over beta divided by, okay, so this is a uniform thing, right? And then it's I have some function of a bar. And S e t over beta divided by some function of r. Let's say this has to be 1. That would mean that t equals S0, S1 1/2 square root. Is this always true? So let's look at BTZ. So BTZ S0 equals u or minus u, and S1 equals minus v, right? So S0, S1 to the 1/2 is minus u over v to the 1/2, and Jesus Christ, I think this will be true. Right, because, well, I don't want want to... I don't know. I don't know. The question is, when does this happen? So, well, let's check this. This is pretty easy to check, right? If we go here and we look for this paper going down to one of the appendix D, I believe. Here, question mark? Yeah. So if I take U divided by V, well, minus U rather, divided by V, I get e to the minus. That's quite incredible. And the same thing happens for Schwarzschild. So there seems to be a pattern. There seems to be a pattern that I should study more generally. I've tried to do this, except it's just failed, right? It's just failed. Yeah. Okay, so the question is, if we go to, which one is it? Somewhere here, half-sided inclusions and analyticity. And we look at this differential equation we get, right? We look at this differential equation we get. When is this local up to scaling? I don't. Care too much. Wait, where did it go? Okay, yeah, so I want to do this more general thing. Yeah. Let's try this one more time. So the problem I thought, there was this differential equation that I can't solve because I have integrals with respect to t. Is it one of these? What is this local acting as a vector field? Yeah. So now I have integrals in terms of t. But now I can crucially use that. Wait, what does this mean? F of, okay. U prime and V prime. Now I'm integrating U prime from 0 to V. Is that it? From U0 to U. What is this F? Let the general solution to this differential equation be F. I can integrate to get a recurrence relation. Oh, I see. So I put this in here. Is that the idea? Yeah, so now I put this and this. Or something. But this is just wrong, right? This is just wrong. What is this local? I don't really know. Should I just do this calculation again? Maybe that's the strategy. But you said there are also poles here, right? There are poles. Simple poles, poles and zeros. This is the Jost function. Wait, there's this missing structure that I seem to not have written here for some reason. I don't know why. Something about poles in the upper half plane at an over beta bar. Something about bound states? Is that it? Yeah, there we go. Analytic properties. Yeah, these are bound states. Bound states are, well, they're bound, right? They don't have any, how to say, decay width. And so, is that the statement, that there is no real component, it's purely imaginary? I don't know. I think so, right? Because the quasi-normal modes, they're all decaying channels. No, that's not true. That's not the statement. Bound states, they live, right? The fact that they're in the... They don't grow. But bounds... I don't know. This is confusing. I need to think about this more. I'm confused. Because if we look at the phase shifts for BTZ, they also have this thing. And if I'm in the positive imaginary plane, this will blow up. Yeah, but this is fine because these get killed by well, no, they don't get killed, it's just D11 and 12. Yeah, no, this is expected. This is expected. So for instance, if omega is I over beta bar or whatever, or I beta. No, omega, beta bar, omega is I, then this will be, gamma of -1 divided by, well, yeah, this thing will blow up. Well, not as it's presented here, but like, if I interpret this as, yeah, I see. I see. But now this is confusing, right? Now this is confusing. These F's, they're not complex conjugates of each other, but okay, so this thing is artificial. So when is HA, how are HA and HR related? Was there anything about that in here? HA, oh, they are related. HA is HR. Interesting. So this is really like a scattering problem, right? Yeah. Okay, I kind of like this then. Oh, well, it's yeah. Okay, I kind of like this. Maybe enough to try to attempt this once more. Yeah.
this is interesting, right? Because usually what I'm supposed to do is, so there are not going to be any branch cuts, but, well, I don't know. In a certain limit, right? So where are there going to be poles? They're going to be poles at omega equals minus Jesus fuck. Let's just do this again. So there are going to be poles at I minus I omega minus omega prime equals minus n, I guess.
I forgot if there's a minus here. Let's take a look. Elasticity scrap. There's a minus. Beta bar.
Yep. So poles minus I beta bar equals minus n, right?
And okay. So we can solve for this.
And this becomes minus I n over beta bar plus omega.
Right.
And in the whatever WKB limit, this will be omega prime equal or tilde omega tilde plus IN over beta bar delta. So this instead of having a sum over poles, this will actually materialize as an integral over these
This will materialize as an integral over these poles, starting from is the origin, right?
So I have I'm integrating along the real axis, and I want to bring this up to I want to
integrate along branch cut. And if I integrate along this branch cut, then it's actually not clear what it'll be. There is this trick to compute the residue at each poles, like so I have this sum, right?
I have this sum as n for n greater than 0. And this sum now becomes integral, which is kind of a strange thing to do. Is it a strange thing to do? I'm not so sure. Well, it is if they're hypergeometric functions. And in the case of yeah, this is the case where This is the case where what? This is the case where I have a sum over a string of poles, which becomes an integral. But I have no idea how to do this fucking integral, right? But I can cast it into a sum, and the sum I can use hypergeometric 2f1 identities to write in such a way. And finally, I can take the delta goes to 0 limit, or delta goes to infinite WKB limit. Is this the correct thing to consider? I don't know. Yeah. Right. Right, okay. I think I know what to do now. But let's take a quick break, shall we? Let's lie down for a bit.
Alright. I am back. Let's try to get some work done before. What is this? Emails. Yes. Screen. Okay, no problem. I think I have a good idea of what needs to be done now. Ooh.
Oh, right. Took a shower. Now, I should call this, I should call this work. I should add another category. Let's call it flag. And let's call it streaming. Yeah. Okay, so I'm streaming. I am alone at home, and let's get some work done. Alright. Open OBS, everything looks good. Put on some music. What is good music? In the vein of, let's listen to Victor, other Victor. November. Okay. I have some kind of idea as to how this works. Yeah, let's scrap 2. Alright. Okay. So now let's talk about general wave function. Consider scalar field in ADS equals 1. In ADS equals 1. Background with time like killing vector. Killing vector. Time like killing vector. Partial. Let's do this. Partial T. We can write the field, we can decompose the field as, so let's write phi of T R omega. So these are the those coordinates, and in 2 modes. That is omega, so now we have omega, we have L, as well as, that's all, right? We have omega and L. Let's do this. Yeah, equals E, so modes as, well, I should really just write Q. Not Q rather, but X and omega and Q. This is what it is. I got an email. Let's see what this is about. Nothing terribly. Okay, so we have the typical story, I omega t. We have spherical harmonics, or not spherical harmonics. Well, they will be if it's compact, but IQ. So vec q, vec x, and we have some function, which I'll call psi of psi of r, right? Psi of r. Now, this thing, psi of r, will satisfy the radial equation of motion. It has two solutions. We want boundary conditions. Scalar field of mass m. We want boundary conditions. Psi r to r, is it 1/2 minus mu? There should be right, there should be that thing there. Where would this be? This would be, yes, 1/2 minus nu. Well, this is z. Where for z are the torus coordinate. Okay, doesn't matter so much what that is. Yeah. Okay, we can also solutions. So this is, so can decompose this as ingoing / outgoing solutions at boundary, at the horizon. So let's write this properly, right? Yeah. Oh, whoops. I want this to be plus because I want this to decay. And the deconstruction I want is the following thing. So at the horizon equals, I can do this decomposition quite easily. So we have these phase shifts. This is how you define these phase shifts. Delta omega q minus u. Oops. This is I omega. And this should be a minus sign. Whoops. Plus this thing. This is here. V. This is how these phase shifts are defined. Phase shifts have poles at so this is let's see if I can write this properly as, yeah, equals, so I can pull out the Rindor part, right? Let's call this thing gamma. Gamma I and omega, or theta bar omega, and there's a negative here, but all of this is really raised to the 1/2 power, right? Let's think. have poles at omega equals omega equals at polynomial modes of black hole space-time. So yeah, this would be I n over beta r. So n is greater than or equal to 1. So these are it all in h minus. So this is like same as linear. Yes. So there's a question I have. So question. Why are the first set of poles there? I would think that poles of this space-time are precisely quasi-normal modes. Yeah. So away from the, so this is kind of I bold this away from the horizon. Oops. Let's bold this and f of omega q. Oh yeah, and here this would be like e to the I vec x vec q. So here this thing will be, it'll depend on omega q node q equals vec q, something like that. I believe. Yeah. This will depend on these modes, and this will just depend on that. Omega q r. Or perhaps I should put these first. I think that's probably for the best. That's fine. Away from the horizon. Right. So now there is there is this thing. Phase shifts, and it's, if I put a minus omega here, that's the same thing as have poles properties of phase shifts. Right, so first property is there are poles. Second property is if I put omega here and omega here, then this is going to be whoops, well, yeah, without, it'll just be the inverse here. Well, this is kind of like conjugation. And I do have a question. What is the first set of poles in H plus? Or H minus, if that makes you happier. Right. F R. Right. So these are kind of like the Jost functions, and these things should be smooth. Yeah, story should play out like this. And this should be Is this true? I think this is true. Yeah, that's how this works. Well, there's this property. Right. Nice. Okay, I think this is fine. Let's make this pi z, actually. The equation's 2.40. And we spectral density. Yes. So, I mean, in principle, I should really do this. R minus d minus 1 over 2. It's fine. Yeah. So when d equals 2, yeah. When d equals 1, there's no factor here. Oh, there's a minus omega t. How could I be so retarded? And yeah, this seems to be what we're saying, right? Perfect. That's under F. We're by construction. Yes. Wonderful. So this is my starting point. Property. Where, so I should not call this F, I should call this H. Or H of omega Q is analytic. Is entire, I should say. Right. Let's see what properties this thing has. Joss functions, yes. Analytic. H of R is analytic. The only singularities are simple poles. Is this true? Located at Is that the trick, that these things cancel each other out? There's something that's a little not clear over here. So at given z, G is analytic. Really? This is confusing. F can only have zeros at the upper. I wonder if there's some mixing going on here. You say that G is analytic, but maybe... Because, like, in principle, I could just multiply by something that's very non-analytic, and then I would be fine, right? Like, given G, H of R is analytic in the low upper half plane. H of R, what is H of R? H of R is this thing. Well, should I be at least consistent? No, it's fine. I think it's fine. Why is G analytic? And if I continue this away from the horizon, then I'm confused. So, example. Let's write this as an example. Whoops. Example PTZ. So that's here, and this should be here. Yeah, let's write this thing out. So full wave function with vanishing boundary conditions, right? ADS Swindler, that's fine. Yeah, so so I should call this the full wave function. So omega q and t, so yeah, omega q, and let's just call this thing phi, and so we have tr and well, tr and what? And vec x is just chi, I think they call it. Yeah. Equals nk. Well, yeah. Nk 1 plus uv 1 minus uv delta e to the I q chi. And now we have 2v to the minus I omega 1 minus uv to the I omega hypergeometric 2f1 delta plus I omega minus rather omega plus q over 2 minus omega minus q over 2, and we have delta here, finally 1 plus uv 1 minus uv squared. What is nk? This would be on, I think, page 50. for nk equals, this would be, yeah. This is 1 over 2 pi gamma delta sinh pi abs omega. And what this is I have the following: gamma q plus gamma so really I have all of the combinations of this thing, minus, plus, and minus, minus raised to the 1/2. So just hit nk equals this thing. Yep. But I have a formula that I can use. Where is it? I think it might have been here. Yeah. Aha, no. No, not quite. Large delta limit. Motherfucker, where is it? Might be up here, even farther. I thought it was chapter 2, maybe? Aha. Sinh pi x over 2. So this thing is, I can write as pi 1/2 abs omega square root. So I'll put you here. Jesus. And I have gamma I omega gamma minus I omega. Right, and that's the cost so this pi goes away here. This thing goes away, and all I'm left is this thing. Raised to the 1/2 power. Beautiful. Now let's take this and put you here. So this is nk. I want to go to uv equals 0. Go to uv to 0. So basically the idea is I want to series expand uv 0. Oops, uv 0, 0. Full simplify. Let's make this q bar minus, and this is q bar plus. Okay, I've done this problem before. I've done this calculation lots of times before, I'm sure. But yeah. nk is here. This is goes to 1 or 0. This is yeah, this thing goes away. This thing does this. U1 goes to 0, this thing goes away, that thing stays, and normal. Right, now let's see. This thing get done. So what I really want is Q bar minus Q bar plus Q minus Q plus. Yeah, so Q plus Q minus Q bar plus Q bar minus. And these deltas, gamma deltas go away. Interestingly enough, I pick up a pi factor, but this should go away with the cosecant thing. So Q bar minus. So Q bar minus. So this is Q bar plus. Q bar plus. Q bar minus. This thing Q plus goes to. Q plus is this thing, and Q minus is this thing, except with a flip. Right. So I think the point of this is to if I put a minus in front of the whole thing, that changes this to Q plus, right? And this changes you to Q minus. And this is probably like, yeah, what is this thing? Okay. Sure. And what is this thing? Okay. What is this thing? Okay. Yep. And this thing is. Whoops, this thing is this. Finally. Here we have it. Let's put a 4 here. Yep. Put this here. And I can push this here, push this here. Yeah, why is there a... I think something's wrong. Yeah, something is wrong. Ugh. Q bar minus. And no, this is Q bar minus. And Q bar plus is this thing. Can I give it a rule? Child GPT. So I omega gamma 1 minus I omega. Whoops, this should be sinh, right? Equals minus I. Okay, that's true, and I want to I have a mathematical expression. I want to write all sinh and such terms in terms of gamma functions using yeah, what is the mathematical code to do this? Transform rules. Sinh Z rather. Gamma Z 1 minus Z. Z over pi, oops, no I. Is that the correct expression? I see. Cosh is just the reverse of, well, it's just the reverse of this, right? And now, I do this. Minus and plus, and this is okay. My bad. This and this. Transform trig to gamma 1 and transform it to gamma 2. I should call it that, and what I'm doing is I'm doing transform train to gamma 1. Right. Full expand all. So transform, let's see, delta transform, well, simplify momenta equals how do I do this? Right. This is Q minus, and I just copy paste this. 1, 2, 3, 4. So this becomes Q bar plus. This becomes Q bar minus. Q bar plus is setting up some. Yeah, this is Q. Well, this is Q plus, and finally this is Q minus. Expand all, and expand all. Simplify momenta. Oh, beautiful. That's very nice. That's very nice. Okay. Yeah. So now I just have to plug this and this. Yeah. Now this hypergeometric function, all it becomes is this thing now. Right? Yeah, beautiful. So if I take, that goes to 0, this I can pull out here. So this is going to be Q bar plus, Q bar minus, Q plus, Q minus. Nice. 0, 0, that's just 1. Alright, it's not so bad. Full simplify. Even easier. Okay, now this thing will kill this thing. As we've seen. Now we can bring this here, we can bring this here, we can bring this here. So 2v will kill this and this. Alright. Oh, yeah, except, no, that's perfect. That's perfect. Can keep on, we can bring this here, and bring this here. So Q bar minus, Q bar plus. This will get rid of these guys. This will come here. Oops. This will come here. And this will come here. And also, this will cancel out. So now what we have is this gets cancelled. Very nice. And finally, I can bring this factor of 2 out. 2 to the I omega, 2 to the minus I omega. Yeah. Oh, whoops, I don't know why this is still here. Where is the... Here we go. Go back to, whoops, page 100 or so, where we have this equation, question mark. Yeah, this equation. Yep, that looks good. And that's just like saying we have this to the minus. Yeah, let's replace this with this, and yeah, that's exactly what we want. So we also have this factor, which is like great. Right. And this thing this thing becomes this is e to the I delta omega q, right, where omega is this thing. Feels nice. And this is, whoops, just this. Right, so example, yeah, but generally, let's think about what happens generally. So this is this thing, and I should put, well, I should put these here really away from horizon. What happens? So it's really just taking this thing and looking at it generally, right? So what is UV? UV. Where are these coordinates defined? ETZ mode functions, that would be a little bit farther. Or you define BTZ coordinates as, nope, no. BTZ, aha, so here UV, really, yeah, UV equals, minus UV equals 1 minus W over 1 plus W. Because if I multiply them, yeah, then that goes away. So whoops. Now let's simplify. So this is just W, right? Yeah. What about this thing? Over 2B. This is also just W, which is fine. So this thing, but U is minus square root E minus T, and V is 1 minus W, 1 plus W, E to T. Assuming W greater than 0, W less than 1. Gotcha. So let's pull out an e to the I omega t. I omega t, which is what we expected to have, right? Over here. And this becomes 1 minus W, the minus I over I omega over 2. Not half bad. Right in W, so TW coordinates. Yeah. So this is fine in 3 dimensions. We pick up oh, that doesn't really matter. And NK, yeah. So what is NK? NK is there's this Kummer, this thing. K1. Full simplify. Nice. Can I expand all? And I want to simplify momenta. Right, because you won't like this. Okay, that's very nice. And can I simplify again? Do I want that? I don't think I want that. Yeah. Well, maybe I do. Because then these things are just incredibly nice. W minus UV equals solve this thing for W. Yeah, this thing should be W squared. W squared. Right, because that's squared. All right. Maybe not just yet. Simplify. I'll do this. Okay. And let's plug in NK. Q bar plus, Q bar minus, oops, Q plus, minus. Oops. And we have NK still, right? Motherfucker, why does it fucking... Oh. Jesus Christ. Okay. Does it... I did save it or something, right? Alright. Yeah, how is this thing related? It's like... I don't know. Okay. This gamma and this gamma cancels out. I get this, and I get this. It's fine. This is fine. This is also expected behavior. Extract that. And then, let's pull you up over here. Right. So, throw you in here, and this is going to be a squared. So that's going to kill you, it's going to kill you, and it's going to kill you. Nice. And also, I can throw you in here. So this kills you. And now also these guys are donezo. Yeah. Alright, that's honestly pretty fine. Let's bring you here, let's bring you here. And so, what is the verdict? The verdict is now I can use this thing. Throw you over here. So I can write this as this thing. And similarly, so this is just this flipped, right? Flip, flip, flip. So because of that, I can now write this as a minus, and this is a minus. I see. Okay, alright. Well, that will be 1 over 2. And if I'm doing square root, then this would give me a quarter. Right, because square root, yeah. Over 4, and let's see if the same thing happens here. So if I want to do this, then I'd have to do 1 over 2. If I divide by 2, I have to multiply by square that squares, and it perfectly gives me a 4. Okay, so the moral of the story. I see. So 1 over gamma 1 minus I omega. I have to now multiply by this thing. So this would give me regularized. Yeah. Okay. And now, well, whatever. If I divide by that, now I have to multiply by that. And now this gives me something that's pretty good. So the moral of the story is that this now has poles. I see. Oh, whoops, this will be plus. Okay. This is a little curious because if I take a look at this thing, which is, of course, this thing, and so let's compute what this thing is. So not ready for the moral yet, but so this thing would be this thing and this thing again, right? So minus I omega and this would do that. So now I can kill these together. And I can add 1 at the expense of getting I. And now this thing has a string of poles on. Did I do this upside down? Okay, so this is just an identity, and I put you like this. So here I have this this guy, right? It's going to kill that. Gosh. Regularized. So I'm going to get, yeah. So we have a string of pulls. I guess the moral is that you can just... what is the moral? Not too sure what the moral is. I think the moral is the following. You can do this at the cost of this raised to the 1/2. And this with this. So now we can bring this in, we can square it, and I'm going to full simplify. Yeah, something like this. And whoops. Right. So we have this and we have this. And we can just kill it by doing this. Moral. So form 1, and this is form 2. When omega goes, W goes to 1, I suppose. Yeah, so I think this is the thing I should look at, right? So the moral, well, but then yeah, I can get rid of this. If I want G to be regular, then yeah. But even then it's not regular, right? So moral phi equals this thing, which is what we expect. And then we have e to this thing, f, omega f, well, I didn't call it f, let's call it r, right? Now the only difference here is I flip these guys around, plus, minus, yeah, the only difference is I flip this around, and yeah. Where where what? Is this thing analytic? This thing is analytic except when that thing is not analytic. So this has poles. It has poles in weird places. It has poles in this is fine. This thing is not fine because where is this? Yeah, it looks like this. So this thing has lots and lots of poles, which I don't like. Moral. Where? Yeah, when is this thing singular? The thing is singular in the lower half plane, right? Q bar plus simplify momenta. This thing, solve equals minus n omega lower half plane. Yeah. Has poles at omega equals in over beta. Well, and modes in H minus H omega has precisely R has precisely poles at omega equals what is this thing equals solve equals minus n omega equals minus I n equals 1 equals n equals 1. Yeah. Else regular. Okay. Guess I can work with that. Moral 1. Moral 2. So let's call this H. Let's call this G. Right. So I can put this, yeah, this doesn't matter. This doesn't matter either. Well, I don't know. G. Right. Regular, this is entire, that's entire. And this is also entire. The only thing difference is I flip U. That's alright, quite alright. Yeah. Where? Where? E gamma that is precisely equals at quasi-number modes and H minus, and G omega Q R is entire. So not to be confused with G in Vespuccia. Okay. That's good. That's good. Right. So let's make this a cinch. And yeah. Right. there are two ways of viewing this. Or equivalent 3. So if I look at this thing, right. Then that'll just pop off. Yeah. I think I can do this, right? This thing. I think so, yeah. So that'll get rid of that. That'll get rid of that. Yeah. All right. That's kind of, yeah, that's really, really good. That is really good. Is that the form I want, though? So both of these forms are useful. Right. Is that how they're related? I believe so. New horizon transformation. Nope. Somewhere in here, expressions for the transformations. Yeah. E to the I delta. Perfect. Yeah. this is probably the better way to think about things, right? So for BTZ, setup. Okay, so this is like 0 setup. Scalar field and curve sparkle space-time. So let's talk about the... No, don't freeze, you motherfucker. Okay. We'll have the equation of motion. Equation of motion, and so this should be like... well, I can make this 5, I suppose. And let's make this 6, I guess. Equation of motion, solving solutions to equation of motion. And here I have example BTZ. Everything looks very well, and now I can finally talk about so half-sided translations. Nice. So let's do C minus AK prime equals... Yeah, you are simpler. Okay. Well, live and learn, right? So K prime S, I should say, C minus equals switch. I feel like I alternate between these two expressions, which is simpler, which is more complicated, and so on. Gamma K. Well, it's just, yeah, gamma K is fine. Minus gamma K prime. And yeah. So omega prime, omega prime, omega prime, S. Well, Q prime, I suppose, and e to the I delta, e to the I delta. So this is this, right? S minus I, omega minus omega prime, gamma I, omega, omega minus omega prime plus epsilon. Oh, but I want to reverse these, right? Yeah. Well, I mean, I can just take a look at what I have here. Yeah, so I actually want K prime K. Let's just go all the way up here, because I've done this before. Or maybe, where is it? Is it in the second section? Yeah, it is. So, bar, I suppose. Let's do this properly now. And C minus I K prime minus I K, yeah, minus S I beta bar, beta bar. Yeah, this is it. And, well, yeah, so focus on C minus for now. So this is VK X S equals C minus K prime K S V K prime X. Yep. Okay, now let's compute. Well, it's not quite true, right? There are, yeah, okay. Unitary automorphisms of the algebra. What I really want is lambda minus for now. Yeah. Half-sided translations. So this should be VRR. VRR. Yeah. VRR. And let's focus KXS greater than 0. For S, and for S greater than 0, we have the following structure. Equals, we have sinh phi and the prime, or there's maybe a beta bar here. C minus K prime K minus S. Right. Now compute. This thing. This thing. This thing. And what's this? Whoops. And this now V. B right. This is just what I plug. Prime. Well. put these everywhere. Yep. Bruh. I should really make these like that and that. Same thing here, really. Okay. And now we just do it, right? So this is like a square root. And oh, wow. Okay. So this gets in, by the way, this thing gets squared. If this thing gets squared, oh, yeah, we can afford to do that. If this thing gets squared, then that goes in. It kills that. Well, it doesn't kill, but it flips these around. It flips these around. And, well, this kills this. This kills this. And let's put this here. This kills this. Oops. This is like this. Oh, fuck. Fuck! Right. Right, now let's compute this disgusting thing. That looks good. Okay. So the way to do this is to drag all of these to the front. This is a square root, so it belongs in here. This is a square root, so I can square it. And this is also belongs in here. Okay. So absolute value of beta bar omega. This gets killed. This gets killed with this. This gets killed with this. And this gets killed with this. There should be absolute values here, but yeah, I'm being lazy. And now I can bring this thing Yeah. So this this will make all, well, the prime, all these should be primes. Prime, save, yeah. Right. Okay. So, what is this? Abs, beta, bar, omega. Right, so if I do this, that brings this out here. Pi. Okay. I like that. So that's fine. This needs to go here. This is not like, this is like vec q vec x. Well, no, that's right, but this is like vec q vec x. And this is q, that's fine. Vec q vec x. Yeah. So this thing should be like, well, that's fine, but this should be like this, vec q prime, rather. Yep, that's fine. And this should really be like, I should have beta bar be explicit here. Well, beta bar omega, beta bar omega, beta bar omega. Away from the horizon, beta bar, vec q. So it's like, that's fine, that's fine, that's fine. That's fine. This is all fine. Or beta bar, beta bar, beta bar. This is all fine. Yes. Yes. So this should really be omega prime, vec q prime. Well, no, this is going to be q prime. And omega q. So q equals vec q. Right, so the idea is I want to replace all of these q's with q primes with q's at the expense of getting rid of this guy. Yeah. Looks pretty good. now I want to decouple this. So this is good because it's like canonical, so to speak. Yeah. And now this is no longer canonical, it's just like so. Alright. And now this is fine because I can put a beta bar here at the expense of dividing this by a beta bar. The idea now is I can use this, I can stick this in here. Nice. Yeah, that's fine also. And I do want to put something like this here, so let's just do it. Well, maybe not yet. Yeah, not yet. Well, no. Let's do. So each of the I omega t. Now let's do this. So again, there's the trick where I divided by where you these cancel each of the. Yeah, I get something like this, right? And this is good. I want to take this out. So this is now here. I put it here. This gets doubled. This gets killed. Right. That gets killed. And we have the following thing. So this should really just be int. I don't know what this is still here. Yeah. This I should put here effectively, and same thing here. Oh, okay, so now this becomes interesting. So, case one, well, so integration by contours for small s can always close in h minus, provided asymptotics of d not too crazy. So actually this can be modified. Oh, sorry. This should be prime still. But here now it's not prime anymore. So simplify, compute Okay. So for I can always close this in H plus, right? Because if this becomes very big, that's suppressed. For large S, can always close with H minus. And this, so define S1 plus as maximum value. So S 1, 2, S plus, I guess, S plus 1, 2 as maximum value as we can close terms 1, 2, and H plus. S minus 1, 2 is the minimum value of S we can close in H minus. Assume S, sorry. S plus S1 S plus 1 equals S minus 1 equals S plus, and S2 plus equals S2 minus. Yeah. Expect for BTC, it's just the year term. So let's see, Moral 1, Moral 2, yeah. So, whoops, that is a very bad thing to do, but if we go back here, then away from the horizon, or equivalently, my first term is v to the I omega term behaves as at horizon. Second, wait, v to the minus I omega as minus u. Whoops, and this is minus. Yeah. Still the same as true. In both. Both cases, the first term. Yeah. Yes, okay. Yep. Expect. Do we expect this to decay, or what? Yeah. Expect. So we have v. So I go from, this is u less than 0 and u is greater than 0. Here v is greater than 0 the whole time. So we can continue the v terms. equals S equals S. Let's just call this S1 equals S2. Expect S1 so this is for this U. So the first one is V, is that correct? Yeah. This is like V. V U. SU and SV maximum minimum value of, let's just say S. So the first term, e to the v to the minus v to the minus, yeah, S1 greater than S2. S1 greater than S2, or equal. So this can continue, can analytically V terms past horizon, but not U terms. Right, that's all right. Nice.
Well, I've been here before. Sat on the floor in a gray room.
Call S1. Therefore, define S2. S2 equals S minus. And
someone is praying, then I might
S1
out.
S plus
Desolate. Even if I
max.
scream,
So
I can't
min.
sleep. That
Oops. S1 bigger. Should be S. Well, S2 equals S plus.
crawling back home.
This is confusing. Alright, well,
Well, I've been here before. Sat on the floor in a gray mood, where I stay up all night, and all
Yeah.
that I write is a gray
B. Let me call this U.
Pray for me,
U
child,
and U.
just for a
So we expect
while,
S1
that I
and
might
S3 to be greater than S2, since we can analytically get the V terms past horizon, but not the U terms.
pray for me,
Therefore, we
child.
define
Even a smile
SU is S plus and SV.
now.
So these are the maps.
More
min values, we can close the entire integral, C k prime k vk integral, well, k prime k s v k prime x integral n h plus slash minus. So the first term is v-like, so we expect it to be bigger. So how can we assume this is from it's just from expect. Whoa. Why? Why? Since U modes, V modes have well-defined asymptotic behavior. Or the single asymptotic behavior. No, just two examples. Right. So, to do, how can we prove these expectations, how can we prove these assumptions? We'll use strong words. Should be able to use results from scattering theory. Yeah. So region 1. This should be 4. And this is kind of like setup. Yep. So let's take this over here, set up. And now we go to region 1. S is less than S. S is less than S plus. Or really. Yeah. Okay. Yeah, let's all okay. Yeah. Can close both terms in H plus. H pulls. First term pulls at first term. Well, yeah, so pulls. Pick up pulls. First term. So this is the B term.
We were good when we were good. We were not misunderstood.
Only for both only pose
Wish that
at
I could say the same when we left you there.
so
Am I the greatest bastard that you met? The only one you can't forget? Am I the one your truth's been waiting for? Am I just dreaming once again? And dreams are better when they end. Some make it, mistake it.
fuck.
Some force and some will fake it. I never meant to let you down.
It should really be a dimensionless integration, right?
Some let it, forget it. Some ruin and some regret it. I never meant to let you down.
Oops. Add.
Learn to wag and tuck our tails. Learn to win and
Omega.
win.
Well, let's just do this.
Learn that lovers love to sing. Little Am I the greatest bastard that you know? When will we learn to let this go? We fought so much, we've broken all the songs.
G.
Letting go is not the same
Omega.
as someone else away.
R is higher. And
So please don't let
this
up.
thing.
You don't know me. Please don't let up. I'm not here. Please don't let up. You don't love me, 'cause I know you
Right.
do. I know.
And now I can just
Some make it, mistake it. Some force and some will fake it. But I never meant to let you down. Some fret it, forget it. Some ruin and some regret it. But I never meant to let you down. I never meant to let you. I never meant to let you down. I never meant.
What's this? I need this thing. Okay, that's quite nice. That's the first term.
I made you laugh, I made you cry, I made you open up your eyes. Didn't I?
Oh yeah, I have to multiply.
Helped you open up your legs and made you things.
Right. Can I simplify this?
Am I the greatest bastard that you know? The only one who let you go.
Beautiful.
One you hurt so much you cannot bear. We were good when we were good. We were not misunderstood. You help me love,
Right.
you help me live, you help me learn how to
simplify.
forgive.
Together.
Wish that I could stay the same when you left didn't you? Am I the greatest bastard that you met?
So the V
The
term
only
is
one
the
you
first
can't
term.
forget? Am I the one your truth's been waiting for? Am I just dreaming once again? Dreams are better when they end.
Nice.
Some make it, mistake it.
And
Some
this
fall
becomes a sub.
and some will fake it. I never meant to let you down.
Right.
Some let it, forget it. Some ruin and some regret it. I never meant to let you down.
Well, I can call this Z, right? Like, it doesn't make that much difference.
We learn to wag and tuck our tails, learn to win,
Z.
didn't we? We learned that lovers love to sing,
Z.
that losers love. Am I the greatest bastard that you know? When will we learn to let this go? We fought so much, we've broken all the charm.
Now, what we can do is we can
Letting go is not the same as pushing someone else away.
just, you know, put that here. And
So please don't let on. You don't know me. Please don't let on. I'm not here. Please don't let on. You don't love me, 'cause I know you do. I know that some make it, mistake it, some force and some will fake it. I never meant to let you down. Some fret it, forget it, some ruin and some regret it. But I never meant to let you down. I never meant to let you. I never meant to let you down. I never meant.
Nice. Yes, okay. And this just comes down to putting a minus sign here. Right. That gets washed. That gets put there. And so we can put this in parentheses.
I made you laugh, I made you cry, I made you open up your eyes. Didn't I? I helped you open out your wings, your legs, and many other things. Didn't I? Am I the greatest bastard that you know? The only one who let you go? The one you hurt so much you cannot bear?
Compared to original.
You were good when you were good.
And what is the original? The original is this thing. I just have to replace
love, you help me live, you help me learn how
Cool.
to forgive. Didn't you?
Yes.
Wish that I could say the same
Thank
when
you.
you left your
Next.
life blame. Didn't you? Am I the greatest bastard that you met?
Yeah.
The only one you can't forget? Am I the one your truth's been waiting for? Am I just dreaming once again? Some dreams are better
Yeah.
than the end.
All right.
Some make it, mistake it, some force and some will fake it. I never meant to let you down.
Yes. Compared to original.
Some read it, forget it, some ruin and some regret it. I never meant to let you down. We learned to wag and tuck our tails, we learned to win and then to fail. Didn't we? We learned that lovers love to sing and that losers love to play.
So this gets transformed into.
Am
the
I
song.
the greatest bastard that you know? When will we learn to let this go? We fought so much, we've broken all the charm. Letting go is not the same as pushing someone else away.
And
So
this thing.
please don't let on. You don't know me.
transformed.
Please don't let on. I'm not
Well,
here.
it's the same thing.
Please don't let on. You don't love me, 'cause I know you do. I know that some make it, mistake it, some force and some will fake it. But I never meant to let you down. Some fret it, forget it, some ruin and some regret it. But I never meant to let you down. I never meant to let you. I never meant to let you down. I never meant.
Yeah.
I made you laugh, I made you cry, made you open up your eyes. Didn't I?
Oh, what the
I
fuck?
helped you open out your wings, your legs, and many other things. Didn't I? Am I the greatest bastard that you know? The only one who let you go? The one you hurt so much you cannot bear? We were good when we were good, we were not misunderstood. help me love, you help me live, you help me learn how to forgive.
Time is that?
Didn't you? I wish that I could say the same, but when you left the blame.
If I multiply both
Didn't you?
sides,
Am I the
Not
greatest
bad.
bastard that you
Sorry.
met? The only one you can't forget? Am I the one your truth's been waiting for? Am I just dreaming once again?
so
Dreams
V
together
term.
again. Some make it, mistake it, some force and some will fake it. I never meant to let you down.
And this is 4.
Some let it, forget it, some ruin and some regret it. I never meant to let you down. We learn to wag and tuck our tails, we learn to win and then to fail. Didn't we? We learned that lovers love to sing and that losers love to claim. Didn't we? Am I the greatest bastard that you know? When will we learn to let this go? We fought so much, we've broken all the charm.
What is this local?
Letting go is not the same as pushing someone else away. So please
This is,
don't let
like,
on
familiar.
you don't know me. Please don't let on I'm not here. Please don't let on you don't love me, 'cause I know you do. I know that some make it, mistake it, some force and some will fake it. But I never meant to let you down. Some fret it, forget it, some ruin and some regret it. But I never meant to let you down. I never meant to let you. I never meant to let you down. I never meant.
What the hell is this song? Local expressions. Local expressions. So compute. Bruh. Compute value for by keep being only plus the one term sweeping off s factor multiply by I. No, well. So
Made
this
you laugh,
is
I made you cry,
then
made you open up your eyes.
dividing by is
I helped you open at your wings. Your
right,
legs
because
and
this will be like 5
Didn't
plus I
Am I the greatest bastard that you know?
plus
The only
this.
one who let you go.
so now I
When
need
you
to
hurt
divide
so
by
much you cannot bear.
yeah.
We were good when we were good. We were not misunderstood.
But that's easy. So commutator 5.
Help me love, you help me live, you help me learn how to.
So with a d minus
Didn't you?
and phi k of x.
Wish that I could say the
Equals.
same. When you left blame. Didn't you? Am I the greatest bastard that you met? The only one you can't forget? Am I the one your truth's been waiting for?
So
Am I just dreaming once again?
get rid of this.
Dreams are better when they end.
Take n equals to 1.
Some make it, mistake it.
1
Some
over
fall
I.
and some will fake it. I never meant to let you down. Some let it, forget it.
Yeah.
Some ruin and some regret it. I never meant to let you down.
Alright. So let's
We learned to wag and tuck our tails. We learned
keep
to
this
win.
factor
to fail.
and do this separately.
We learned that lovers love to sing and that losers love to play. Am I the greatest bastard that you know? When will we learn to let this go? We fought so much, we've broken
This
all
thing.
the charm. Letting
Yeah.
go is not the same as pushing someone else away. So please don't let up.
5 plus.
You don't know me. Please don't let on. I'm not here. Please don't let on. You don't love me, 'cause I know you do. I know that some make it, mistake it. Some force and some will fake it. But I never meant to let you down. Some fret it, forget it. Some ruin and some regret it. But I never meant
Right.
to let you down. I never meant to let you. I never meant to let you down. I never meant.
So it's like this is the first G, and then this is for the second G.
I made you laugh, I made you cry, I made you open up your eyes.
But really,
Didn't I?
there are these things here.
I helped you open out your wings, your
And
legs, and many
minus.
other things.
So if that's minus,
Didn't I?
these go away.
Am I the greatest
Yeah, these
bastard
go
that you
away.
know? The one who let you go. The one you hurt so much you cannot bear. We were good when we were good. We were not misunderstood.
Nice. Basements.
You help me love, you help me live, you help me learn how to forgive.
Question.
From you, wish that I could say the same. From you, love, feel that blame. From you, am I the greatest bastard that you met? The only one you can't forget? Am I the one your truth's been waiting for?
When is this action local?
And this gives me a very natural question, because this is like, so if I ignore, not ignore, but like, when can this be written as a polynomial of, so like, the thing is, yeah. When is this thing? Is a poly omega q times this thing. And what is this thing? Is a polynomial times this thing. Then this should be the same polynomial, right? Yeah. So criterion for locality. Question mark. So that means I can get rid of these, and that means I can get rid of these. Okay, so this is a differential equation. Right in terms of s plus s minus 3 coordinates. But I don't know how to do that, besides the fact that s is equal to, or maybe I do. We'll see. If I use that, then I get a differential equation. So for s, this can actually be written in terms of
Alright. Let's call it here. I'll be back. This is where things